Hello everyone, welcome back to Get Java. In today's video, we will be seeing what is type conversion and typecasting in Java and what is the difference between type conversion and typecasting. Let's consider a real world example. Suppose we have 4 different buckets having different carrying capacity. So for example, first bucket is having 2 liters capacity, second bucket is having 4 liters capacity, third is having 8 liters and fourth is having 16 liters of carrying capacity. Let's consider case 1. Suppose we are trying to pour water from the smaller bucket into the bigger bucket. In this case, there is no possibility of water loss because all the water from the smaller bucket can be easily poured into this bigger bucket and there will be no water loss. Now let's consider another case in which we are trying to pour water from this bigger bucket into the smaller bucket. In this case, there are two possibilities. In the first scenario, if this bigger bucket having 4 liter capacity is carrying just 2 liters of water, and if we are trying to pour this water into the smaller bucket, obviously there will be no water loss because the smaller bucket also has the capacity of 2 liters. In this case, it will accommodate all the water. Now suppose the bigger bucket is having full capacity of water, like it is having water up to 4 liters, and now we are trying to pour water from this bigger bucket into smaller bucket, then obviously the smaller bucket can accommodate only 2 liters of water and remaining water will be wasted. So in this case, water loss will happen. In context of Java, the case in which there will be no water loss is called type conversion, and the case in which water loss can happen is called typecasting. Now let's see how it happens or how it works in Java. So let's first see type conversion in Java. So we have this 4 bucket and each bucket is having different capacity. Let's consider the first bucket is having capacity of byte. Now as we have seen in a previous video, byte is having capacity of 8 bit. It can store information up to 8 bits. Short can store up to 16 bits. Int can store up to 32 bits. And long can store up to 64 bits. Now let's take an example. Suppose we have a variable of byte type and it is storing 100. So byte we can consider as smaller bucket. Suppose I created another variable of short data type. Now this byte data type variable can be considered as smaller bucket and this short data type variable can be considered as bigger bucket because the capacity of byte is 8 bits and capacity of short is 16 bit. Now I want to store the content of smaller bucket into bigger bucket. So what I can do, I can just assign short value equal to byte value. So I want to store whatever is present in this byte value variable. I want to store it inside short value. So whatever is present on the right side of this equal to operator will be stored inside the variable. So in first statement, 100 is present on the right side of this equal to operator. So 100 will be stored inside this byte value variable. Similarly, byte value is present in the right side of this equal to operator. So if I am assigning byte value here, byte value will be stored inside this short value variable. Here we are trying to store byte data type value inside a short data type variable. So what Java will do, Java will take this byte data type value, convert it into a short data type value and then it will store it inside this short value variable. So this is done automatically by Java and it is called type conversion in Java, where we are trying to store value from a smaller data type to larger data type. And in this case, obviously, there will be no data loss because we are trying to store value from a smaller data type which is having smaller range to bigger data type which is having a bigger range. Obviously, it can accommodate all the values of byte. And similarly, int can accommodate all the values of short and byte. So this is called implicit conversion or widening. So these are different names of type conversion. Now let's have a look at typecasting in Java. So typecasting is the similar process but in reverse direction. So in this case, we are trying to store value of larger data type into a smaller data type. Let's have a look at an example. Suppose I have a variable of int data type and it is having 100. The variable is storing 100. This can be considered as bigger bucket, and the second data type is byte, and in byte I am trying to store this int value. So obviously int is having capacity up to 32 bits and byte is having capacity up to 8 bits. I am trying to store int value inside byte data type variable. So what I am trying to do, I am trying to store data from bigger bucket to smaller bucket. In this case, obviously there is a possibility of data loss. So when we will try to execute this code at compilation, we will get an error from Java compiler. It will say that, hey man, what you are trying to do? You are trying to store value from a larger data type into a smaller data type. There is a possibility of data loss. So I want to tell my compiler that you don't worry about it. I will take care of the data loss. You just do the conversion. So how I can tell my compiler? To tell my compiler, you just have to mention in bracket the data type in which you want to convert. Suppose I want to convert int to byte, right? We are trying to store int data type into a byte type variable. So you have to just mention in bracket that convert this, take this int value and convert it into a byte data type value and then store it inside this variable. So this is called typecasting in Java, where the developer is manually giving the instruction to compiler to convert the value from a larger data type into a smaller data type and then store that value inside the smaller data type. So this is called typecasting in Java. And it is also known as explicit conversion or narrowing, because the developer is explicitly mentioning it to convert the value into a smaller data type and then store that value inside the data type. In this case, data loss can happen. We will see example of data loss once we start to code. So here we can see conversion of smaller data type to larger data type is done automatically, and it is called widening casting. Byte can be converted to short automatically. Short can be converted to char. So your short is having a range up to 32,767 and char is having range up to 65,535. So short can be kept into char. Similarly, char can be converted to int, int to long, long to float, and float to double is done automatically. And reverse, that is conversion of larger type to smaller type, is done manually. When you are trying to convert a larger data type to smaller data type, it should be done manually. So the reverse, that is double to float, should be done manually. Float to long, long to int, int to char, char to short, and short to byte should be done manually. Now we will see few examples of type conversion and typecasting. So let's start coding. Let's open Notepad. Let's create the class, public class type conversion and casting. This is my class name. Let's create a main method, public static void main string array args. So this main method is very important because whenever you will start executing your code, the JVM will look for this main method. So this acts as a starting point of execution of your code. So we will study more about it in our upcoming videos. So I have written the main method. Let's declare a byte type variable, byte b equal to 50. I will declare another variable of short type, short s equal to b. What I am doing here, I am assigning this byte type value inside the short type variable. So byte is smaller data type, short is bigger data type, because byte is having 8-bit memory and short is assigned 16-bit memory. So byte is smaller, short is bigger. We are trying to store value from a smaller data type to bigger data type. So this is an example of type conversion, and Java will automatically take this byte type value convert it into short type value, and then store it inside the short type variable. Now let's print and see. System.out print ln the value of s is so my code is ready. Let's save it inside Java. We'll keep the same name as my class dot Java. So we have the file ready. Let's open command prompt. Let's compile Java C typecasting. So it compiled successfully. Let's execute the code. See, we are able to print it. Value of s is 50. So this is an example of type conversion, because we are storing value of smaller data type byte into larger data type, which is short. Now we will see another example. Let us consider int. I will just delete it. Let us take a int type variable. Int I equal to 100 and byte b equal to I. So here I have taken an int type variable. So int is a bigger data type. Int can store 32 bits of information and byte can store only 8 bits of information. So I am trying to store int value inside byte type variable. So bigger data type to smaller data type. Now let's compile and see if we are getting the output or not. So the value of b is b. Let's save it. Go to command prompt. Compile it. Okay. Now here we are getting possible lossy conversion. So the compiler is telling what you are trying to do. You are trying to put value from a bigger data type into a smaller data type. So there is a possibility of data loss. But I as a developer know that byte can store value up to 127. We have seen it already. Byte can store up to -128 to 127. So I as a developer know that byte can easily store this value 100. So I want to tell compiler that you don't worry about the data loss. I will take care. You just do what I'm telling you to do. So how can I tell compiler? I can tell compiler by just writing byte here. So I'm telling compiler, you take this int value, convert it into byte, then store it inside this variable, byte type variable. Now let's save and try to execute it once again. Say this time it compiles successfully. I will run. I will execute the code. So I'm getting value of b is 100. So this is an example of typecasting, where I'm taking the bigger data type and storing its value into smaller data type. Now let's see another example. Suppose I want to store a value which is larger than the bytes range. Now int is having 1000, but we know byte can store only up to 127 positive. It can store from -128 to 127, but I am trying to store 1000, which is outside the range of byte variable. So what output we will get? Let's see. Just save it. Let's compile it again and let's execute. See, we are getting -24. So data loss has occurred in this case because we are trying to store value which is outside the range of byte. Byte can store only from -128 to 127, but we are trying to store 1000. In this case, data loss has occurred. So the initial value 1000 is converted into -24. This is called loss of magnitude. The entire value is changed. Value was 1000, now it is changed to -24. So this is called loss of magnitude. Now let's see another example. So this is also an example of typecasting we have seen. Now let's see another example. Suppose I am having variable of char type, having value a. Now I am having another data type of integer I equal to c. Here I am trying to put character value inside a int data type variable. So we know the range for character data type is 0 to 65,535, and range for integer is negative this range to this range. So let's print and see what we are getting in output. Let's save. Let's compile it. See, we are getting value of I is 97. Now you must be wondering, I have assigned a as a literal to char data type. How it is converted to 97 when I am storing it inside int? So every character in Java is associated with some numerical representation according to ASCII standard. So every character will have some numerical representation. That numerical representation we can also check on Google. So let's go to Google. Simply type ASCII value for characters, and here you can go on Geeks for Geeks, and here you can see. So every character is assigned some numerical value. In this case, smaller a is having 97, and it starts from 97, it goes to 122, A to Z. Similarly, capital A is having 65. So every character is having some numerical value associated with it. And whenever we try to store a char value inside a number type data type, then that character type value is converted into the corresponding numerical representation, and it is stored inside that number type variable. Now let's see in reverse what will happen. Suppose I am having a integer I equal to, suppose let's take 100 and take another variable of char type, char c equal to I. Instead of int, let's take byte. Byte b equal to 100 and char c equal to, I'm trying to store bytes value inside this character. Now value of c is plus c. Let's save it and let's try to execute. See, again we are getting this error, possible lossy conversion from byte to char. Now byte can store how much of information? Let's go to the table. So byte can store 8 bits of information, char can store 16 bits of information. But then why it is giving me error, like that data loss can happen? Byte is the smaller data type, char is the bigger data type. I am trying to store value from a smaller data type to bigger data type. Still I am getting this error, like possible lossy conversion. Compiler is telling me data loss can happen. That's because let's see at the range. So byte can store value from -128 to 127. Char can store value from 0 to 65,000. So char can accommodate the positive side of the range, but for negative side there can be data loss. So that's why compiler is telling if you will try to store negative value, then data loss will occur. So it is giving me warning. So in this case also I need to tell compiler that you don't worry, I know what I am doing, you just convert. So I need to tell compiler just convert, take this byte value, convert this value into char and then store it. So let's save it. Let's compile it again. So see, the value of c is d. So this 100, it took the 100, it converted it into D. So 100, we can see 100 is representing D. So 100 is taken from byte, it is converted into its character representation, and then it is assigned to char type variable. So I hope it is clear now. Now let's have a look at another example. Suppose I am taking a long type variable L and I'm assigning a bigger value to it, 1 2 3 4 5 6 7 8 9 1 2 3 L. I have assigned this value. L represents long. Now I am creating another variable of float type, float F. So this is a non-decimal number. I am trying to store it inside a decimal data type variable, float F equal to L. Now long is of 64 bit. Here you can see long is of 64 bit. It can accommodate 64 bits of information. Float can store 32 bits of information. That is, long is a bigger data type, float is a smaller data type. So ideally I should cast it, right? Cast it manually to float. But let's see what will happen if I don't cast it. I am expecting compiler to give me error like possible lossy conversion. Let's see if I am getting that error or not. So I will try to print this. Let's compile it. See, it compiled successfully. I did not get any error. Let's execute. So the value of f is 1 2 3 4 5 6 7 9 e raised to 11. So till here I got the value, and after this digit it got rounded off and it gave me E11. E11 means 10 raised to 11. So why did not give me the possible lossy conversion error? Why it just executed the code? So here we can see this value, initial value, is rounded off and we got some decimal representation of the same value. So this is called loss of precision. We have lost some precision value. The entire value is not changed. In previous cases we have seen loss of magnitude. In case of int to byte conversion, we saw 1000 got converted to -24. So that was loss of magnitude. If there is a loss of magnitude, we have to manually take care of that. Compiler will give error like possible lossy conversion. But here loss of precision is happening. Like this value is getting converted into some decimal representation and it is rounded off to 6 or 7 digit after this decimal point. So this is loss of precision. If there is a loss of precision, compiler will not give us error. If there is a loss of magnitude, the entire number is getting changed. At that time, compiler will give us error, and we as a developer have to decide whether we have to go with the data loss or we don't have to go with the data loss. So there is an exception when we try to convert long data type to float data type, because long data type is 64 bit and float data type is 32 bit. Still we don't have to manually convert long to float as seen in previous examples. In previous example we saw if we are trying to store value from a larger data type to smaller data type, then manual conversion is required. For example, here int value having 1000 as literal, we are trying to store this 1000 inside this byte data type variable. Then obviously compiler will give us an error and we have to manually convert this int value into byte data type and then we can store it. But in case of long to float conversion, we know long is of 64 bits and float is of 32 bits. But when we try to store this long value inside a float data type variable, the compiler will not give us an error. So why does the compiler allows this conversion from larger data type to smaller data type without telling the compiler manually? Because as we can see in the previous example, in this case when we are trying to convert int to byte, there is a loss of magnitude, the initial number is 1000 and it is changed to -24, so the entire number is getting changed. It is called loss of magnitude. But in this case, when we try to convert this long to float data type, so the number is just rounded off and the precision is lost. So when there is a change in magnitude, we have to mention it manually. So that is considered as data loss, major data loss. But if there is a loss of precision, we don't have to tell Java or tell compiler manually to do that conversion. So that is called loss of precision. Loss of precision is allowed and it is taken care automatically by the compiler or the JVM. But in case of loss of magnitude, as a developer, you have to tell compiler that you are okay with loss of the data. That was all for today. We saw the difference between type conversion and typecasting. Also, we saw why long to float conversion is type conversion in Java. I hope you liked the video. If you have any doubts, you can mention it in the comment section. Thank you for watching. See you.